So we're starting a new recording because the first one bombed out with the audio. Okay. So we're opening the PLC Ladder Simulator 2 and we're going to explore the inputs and the behavior of counters. So counters can be found here in this particular component selection button, which looks like a timer. It's somehow uh, associated with timers, although it's just actually a counter. So we have two counters. We have the count up and we have the count up and down. They're quite similar with each other. The differences will be apparent when I show you the two of them. Okay, so let's click on CTU and let's put it on a new rung. Okay, the preset value again is the value that you're trying to aim for. So remember, in a count up timer, the desired value or the preset value is the point at which the after which, okay, on or after which the output signal dn or .dn becomes a high signal. So in terms of the colors that we have in the simulator, it becomes from black to blue. So let's say for the purpose of this demonstration, let's put it at 30. Okay. Now, the C file is actually just the number we associate with the counter. So I normally start my count here at 1. But some will actually argue to start your count at 0. It's also okay to do that because this is a digital platform, meaning to say 0 is considered to be a number. So when we add it in, we actually see that we have an input called CU and we have another input called reset. So if reset is held high, the accumulator or the accumulated value will not change. It will remain at 0. If CU is held high and reset is held high, this accumulated value will not also change. Okay, so reset is the has more power control and power over the CU input in terms of increasing the accumulator value. Okay, so let's add in an input. Okay, make it 1 so that we're not going to disturb the area there above. Okay, and then let's place in 2 here. Okay, so let's try to uh, simulate this one. Okay, so when I click it or it goes from low to high, okay, you can see that the accumulated value is increasing. When I click on the reset button, which is connected to I02 or I2, we get this change of value from the accumulated value to going back to 0. Okay. So when we have multiple times that we trigger this one and it reaches 30, you'll notice that C1.dn changes from black to blue or it changes state. Okay. So any number of the accumulated value above the set point or the preset point or the PV, in some cases the PLC calls it a PV rather than preset value. Okay. The value of C1.dn in this case will still be remaining at the high value. Okay. The only thing that can change it back into a black value or a zero value is the application of the reset. So it doesn't matter if this one is held high or low. If a reset is active, the count will never be considered as valid, or it will not enter as an accumulated value. So let's stop. Okay. So again, we encounter a few more ads. Okay. So next, let's do a comparison between a count up timer and a countdown timer. Let's put one countdown timer here. Let's call it C2. Okay. And then let's have a preset value of also 30. Okay. Let's add in this counter into the program. And you can see with some clarity that C2 has the same outputs with an addition of CD or the countdown output and an input which is CD or countdown input. But the reset is also there, the C is also there. So just for the sake of clarifying, let's put in the same inputs that we had established in the first one. Okay. So this is supposed to be 1 in as a CU. Okay. And then 2. And then let's add in a third. Sorry. I think this is supposed to be 2 because this is reset and this is supposed to be 3 because this is the new input update. Okay. So let's take a look at the behavior. So if I click it, it still increases and we still see CU or .cu terminal lighting up. And if the input signal is high on the CU portion, if it is low, it becomes black just as this one is. Okay. So next, we'll do a countdown. So as you can see here, each time the countdown goes up in the rising edge, okay, from 0 to 1, no, logic 0 to 1, we get a decrease in the accumulated value. And we also get a signal across that CD output. Now, the thing to remember about using a count up, count down timer is that the accumulated value can go negative. Okay, and you can counter it with a count up timer. Okay, so you can change the values here. Okay, so it is expected now at counter 1 that this C1BN will actually go up, okay, or change from low or logic 0 state to logic high state. While this one, since it has not yet reached 30, this thing or this output of C2.tn will still remain black. Okay, blue na siya lahat and still this one is black. We need 5 more pulses in order to get to it to turn to blue as well. But in this case, for the count up, count out timer, you don't really need to place in a reset in order to make the accumulator value go down. You can just add in a signal and then get the qualifying response. Unlike the other one, the count up timer, wherein you have to add in a reset value in order to obtain changing the accumulated value back to zero or to something else rather than a positive number. Okay. So for the usage of counters, counters can be useful to control the signals that we encounter. Okay. In this case, could be the output signal. Let's try to make this output signal change, not just the static value that we have here. Okay. To do that, we can apply in a new signal, which is the output placed back as an input. Okay. And have it set as normally closed. So meaning to say, for a moment's instance, this line will actually turn this one on. When this turns on, this opens up and turns it off. And then when that is turned off again, it is turned on as long as I that 00 is actually made to go to a closed switch contact position. Okay. So we have here the signal. Okay. So let's let the okay. So to change the value of the count up contact that we have here, we can change this one as a reflection of the output to make it a open loop. Okay. But that output is zero now. Okay, update. We can change count up here as zero and out and then turn it on. Okay. So if we do this, we can get that type of reaction to it. Now, setting your pulsating signal this way, well, it allows a pulsating signal, but it doesn't allow you to have a specific time associated with the value of your change out. Okay, this is the reason why we have timers and we need timers. So that would be handled in another video. For now, I think that's enough for our counters. Okay, by the way, if you want to use the counter to control the signal after 30, that it would stop changing the value, place in a counter output. So let's use CPU counter output. So you have to select DN, okay, and have it set there. So let's do a play. Okay, let's do a reset, and then let's do this one. Okay, you can see here that the count stops at the point when C1DN is actually turned on, and this contact point is released from a closed position to an open position. Thereby, you don't have any activity on the out portion here. So after 30 pulses, you get this reaction. Okay. So I think we're done for this one. Okay. So stop the recording now.